Hello, today I'm going to be showing you a brief overview slash tutorial of some neural network code that can recognize simple images and solve simple problems. I'm going to show you how to set up the project in Visual Studio, as well as how to write all of the code and what it does, and how a neural network works. So first things first, we're going to go ahead and create the Visual Studio project. So I'm using Visual Studio 2022. So you're going to go on the main menu and then click Create New Project. You're going to come over here and click Empty Project, and if you don't have this, go to C++, and then you can just type it, but it's usually right here. You're going to click Next, and you can just name it. I'm just going to call it Neural Net, like that. And then I'm going to wait for that to create. And then you can use these filters if you want to, but I usually like to just use normal folders. So I'm going to click this right here to show all files. And then I'm going to go ahead and right click and then add in the new folder and call this source. And this is just to put our source code in. Add new item. Then we're going to be writing this in C, so we'll call this main.c. So now that we have the project created, I'm going to just do a brief overview of how neural nets work. So you have usually neurons, layers, and networks, and it's kind of structured like the human brain, as the name kind of suggests. Basically, you just have layers with neurons in them and networks with layers in them. It's pretty simple. So we're going to go ahead and start writing the code here, and we're just going to be using the standard library. So just go ahead, standard IO, as well as standard library.h, as well as time.h for math functions, setting the seed from the time for randomness. And then I'm just going to put a comment here for activation functions, and I will explain these in a second, but basically we're just going to make some function pointers that take a single parameter. You can just call this activate func, and then it just takes a double as a parameter, and we're going to duplicate this and just call this activate derivative. I can spell that. Okay, so now you can use whatever activate and activate derivative functions you want to use, but I'm just going to be using sigmoid. Some other ones though, like you could use relu, if you know what that is. Basically they're all just different math functions that you can use to train. You could just put like could add relu here. Just gonna put a comment here, and we're just gonna start defining the structures for the neurons, the layers, and the networks. Like type def struct, and then a neuron is going to have weights. I'll explain all these things in a second. A bias, an output, and a delta. I'm gonna name this neuron underscore t. And then for the layer, we're just gonna basically do the same thing, except we're going to just have a number of neurons as well as an array of neurons. And actually, I think you could make this an unsigned int, because you can't have negative amounts of neurons. And then we'll just make that layer t. And then for the network structure itself, we're going to do the def struct, and we're going to have an unsigned int for the number of inputs that we want to give the model, the number of layers. We're going to have an array of layers. We're going to have an activate function, activation. We're going to have an activate derivative, and then we're going to name that network t. So I'm going to define a function called random weight, and then we're just going to return a double of random divided by the max that rand can be. And then we're going to multiply that by 2 and subtract 1. This should just give us a decently small number for the weights. You'll see why this will be useful later. And then we are going to define the create functions for the neurons, the layers, and the networks. Okay, so I'm going to go ahead and define the create function for a neuron. I'm going to go ahead and define the create function for neurons, and then it's going to return a neuron underscore t, create neuron. We're going to create that neuron. We're going to create the weights, so we need to allocate these. We're going to use malloc, and then the number of inputs times the size of a double, and then there needs to be an equal sign here. And then we're going to use that random weights function, and then we're just going to do neuron.weights at index I will be equal to random weight. And then the bias for this neuron is also just going to be random. And then the output, we're just going to initialize to 0. And then the delta is also just going to be initialized to 0. And then we're going to return that neuron. Okay, so now I'm going to do the initialization function for layers. So it's like pretty much the same as the neuron one, just for layers and their parameters. So it's going to take an unsigned int of the number of neurons, and then an unsigned int for number of inputs per neuron, because they can have more than one, and then create the layer, and then the layer's number of neurons, we're going to set to this layer's neurons. We need to allocate those. After we've allocated those, we need to initialize them. There needs to be I. The layer's neurons at index I going to be equal to create neuron number of inputs. So we're going to create a new neuron and then return the layer. Okay, now I'm going to do the creation function for the network. So I'm going to go ahead and create the network structure, and I've misspelled that. And we're going to assign these function pointers, and then we're going to go ahead and create the layers. And then the input layer, the first one, is connected to the first hidden layer. So what we're going to go ahead and do is the first layer here is going to be a different one from the rest of them. So now we're going to go ahead and write a function to forward the inputs to the activations and things like that. And that is going to take a network pointer, some inputs, targets, and the learning rates. So kind of how fast your model learns. Okay, so now we're going to write a function to train the network. And this one is pretty simple. It's going to take a network pointer. It's going to take an array of, or I guess a 2D array of inputs, 2D array of targets, data size, the amount of epochs, and then the learning rate. Okay, so now we're going to write a test function, and what we can do here is put a comment test the network, and we can write void test, then it's going to take a network and an array of inputs, and we're going to forward Okay, so I've made a mistake here. If we go up here, right here, this I needs to be set to 1 and not to 0. This should give you decent, reliable outputs, as you can see. So, for example, in here, if we do 1 and 0, then we should get above 0.5 pretty consistently. And then same thing here, because one of them is true, one of them is false. So that should also give us pretty much the same thing. Or if we have 0, 0, it should be below 0.5. There you go. So anyways, that's pretty much all I wanted to do today. Thanks for watching.